Ignition sequence start. 6, 5, 4, 3, 2, 1, 0.
Welcome to Ignition Sequence. I'm John Murphy, and today we're exploring the future of learning and creativity in an AI-driven world. Our guest, Stefania Druga, is a research scientist and innovator at the forefront of AI education. From her groundbreaking work with MIT Media Lab to her contributions at Google Gemini, she dedicated her career to making complex technologies accessible and empowering communities around the globe. Stefania's journey, from a small village in Transylvania to building tools that teach AI literacy and creativity, is as inspiring as it is transformative. In this episode, we'll dive into how her work is shaping the way we think about AI's role in education. We'll uncover how AI can demystify itself for young minds, transform learning environments, and even help us reimagine what's possible for the next generation. Stefania, welcome to Ignition Sequence. Thanks for being on the podcast today.
Good morning. Thanks for having me.
You're very, very welcome. So first question, obviously, is do you think I'm a real person or an AI-generated image?
I definitely think you're a real person, but it's
Does the future hold, though, that I could be someday an AI-generated image that could interact with you live like this?
yeah, and I think it's a good philosophical question to wonder if I can't tell the difference, if that would matter or not.
You know, AI is just kind of just exploded in the last couple of years. You know, I was just researching it. It's about 2 years ago exactly that OpenAI released ChatGPT, and then all of a sudden we were actually in it. Everybody from me to high-end users and technical people and just the common Joe who loves technology and is science-minded is now immersed in this world, and it's just like going really, really fast. But it seems like we talked about AI and AI technology for like a decade or more. And it was kind of always in the back burner of your mind, like, yeah, someday, yeah, someday, yeah, someday. And now that day is here. And it's, as I said, going very, very fast. And it can be pretty intimidating, can't it?
Yes, I think it's moving fast, or there is this perception of it moving fast for people who have been working in the field or researching in the field. You know, it doesn't feel as fast, but I can totally see from an application standpoint that now that it's being adopted more widely, that it can be overwhelming and scary at times.
Now, you are working with a Google Gemini. And before we talk about that, can you define a couple of terms for us? Like, what is large language model and multimodal AI? Could you explain those for us?
Sure. A large language model is basically a really big AI model, hence the name, and it's trained primarily on text. It's using this technology called transformers, which was described in a paper in 2017 called Attention is All You Need. And basically, what these models are doing is they're trained on very large quantity of text. You could think of pretty much all the text that we were able to digitize or gather from the internet. And they get very good at predicting the next token. So, based on common phrases that people make, and it's almost like a statistic probability of if I say the sky is, that the next word is going to be blue. So they get very good at predicting this next word. And this is the technology that enabled the creation of Gemini, ChatGPT, and all of these applications that we can talk to and ask questions and get answers. And the second part of your question, multimodal AI. So I mentioned this large language models primarily are trained on text. So we started with text, and it's kind of unbelievable that from this ability of doing the next token prediction, we were able to get so much in terms of how well these models are at responding to our questions. And it's all about scaling laws. It's all about how much text do we actually feed into the training for it to work really well at prediction time. But for multimodal, we start to expand like the modalities. So we don't work only with text. We also work with images, video, audio. So at training time, besides the text, we include these other modalities, like we include images, we include text, we include videos. And that means that at prediction time, at inference time, the model is able to give us back not only text, but also generate um, audio as well, or images, or videos. So multimodality basically means the ability to move beyond text and also work with other type of modalities.
You're a PhD researcher at Google Gemini. Tell us, what is the Gemini project and where are we today and what is the hope for the future?
Yeah, I work on a small piece on a big project, so I don't think I can talk about its future. That's not under my job description. But Gemini is an application. It's like a chat application that you could use in the browser, or on the phone. You can install it on any mobile you have, and ask it questions. Ask it to tell you what the weather is like today in Seattle. It's raining. Or ask it to generate images for you, or ask it to analyze a document, or and tell you the summary. And we've been expanding Gemini with a lot of capabilities to be able to plug into the ecosystem of workspaces that Google has. So we are expanding it to be able to look at your email and maybe like summarize email, or start to draft an email on your behalf. Which we can still review, but before sending, or like analyze a document or analyze slides, or think of any of the Google products that currently exist, and kind of like how this tool could be used in that context. I'm working on a very specific extension for Gemini, which is the smart home extension. It was released 2 weeks ago for a public preview. So it allows you from your phone or the browser, but people primarily use it from the phone, to control any smart home devices. So using the model to take actions on your behalf, and let's say like adjust the temperature in the room, or if you say, oh, it's really bright in here, like, and you have blinds, like you would turn on the blinds. So it can do much smarter actions on your behalf in the house, no matter how you give the command, um, as long as you have those devices connected.
Do you see it as a potential, like, for example, the stock market is doing very, very well as we're recording this podcast. It's on a real bull run. Could you do something like, "Hey, Gemini, is it a good time for me to invest X amount of money in the stock market today? And should I do that?" I mean, could it give you some good quantitative analysis on whether you should or not?
If you do that off the bat, I have not tried this query. We could, and just like, but my sense is that it would probably tell you I'm not a financial advisor, and like there are lots of safety filters in place to kind of manage expectations of the users, especially for more sensitive queries, like if it's
Mhm.
asking for medical advice or financial advice or legal advice, like to really set the right expectations, saying like, I'm not a lawyer. I'm not a financial advisor.
Right.
Um, because I think it's very important for people to know that, this technology is not perfect. It operates on the data it was trained on at training time. Sometimes it's like calling in search to get the latest information, but the way we expose that to users, like, needs to be done in a very kind of safe way. So what you could do if you wanted to work on that question is maybe download transcripts of quarterly earnings from top companies that you're interested in, put that into the context and say, based on these documents, can you give me a couple of strategies of how I should invest, knowing that these are my criteria, right? Or like knowing that this is the risk that I'm willing to take, similar how you would do like with a autopilot for any of the investment sites. But giving it more context would help
Right.
for you to get a really good answer. And I think what's unique from Google's offering is that it does have one of the cheapest APIs for developers and the largest context. It's like 2 million token context, which means that you could give it a lot of documents or a lot of information based on which you would want the answer to be based. And the last thing I'm going to say, I think this was 2 weeks ago, like in the API, we enabled access to search. So there's like a knob that you could turn on to say enable grounding, which means that the API and the model now can do search in real time and give you answer based on the latest information it gets from the web.
That's fantastic. I remember when the cloud came out, and it's really kind of this weird thing. People were walking around, and I'm very science curious, but I'm not, a science genius by any means. So when the cloud comes out, it takes someone like me, 6 months or so to kind of wrap my head around the concept of what is the cloud. How is information stored? How is it gathered? How can I access it? How am I protected from it? So on and so forth. Do you see that right now and where we are in AI technology and with something like Gemini, where people are kind of excited about it, but also hesitant, maybe even a little scared and nervous to even try it because they're not sure what's going to be happening?
I worked for a very long time on AI literacy and AI education. So I've been working in this space, like not only during my PhD at UW, but since 2015 when I joined MIT at Media Lab, and I was part of the Scratch team, which is the largest platform for kids coding online. And I built a version of Scratch which is focused on AI. So back in 2015, I built Cognimates, which is also using block-based programming language, free open source. It's still online. People use it all over the world. And it would allow anyone who's non-technical, kids, parents, teachers, but anyone to train their own models with examples of images or examples of text and play with their own models and then use them in programs to kind of demystify a little bit like, oh, how does this work? Like, how can I break it? How can I fix it? What's the level of confidence my model has in a prediction? Like, let's say, I trained a model to to play rock paper scissors with me, but I only used images I found on the web, and my hand looks very different from those images, where it's like I have a different skin tone. How do I make the model work well with my hand? Or I train a model mostly on sketches, but I'm testing it with realistic photos and it doesn't work that well. Or so really providing like a sandbox for people to understand like how important the data that goes in is
Hmm.
in the quality of the predictions, and also be able to influence that, like be able to add, like maybe someone is into something that is like kids are amazing, like they would train models to do backhanded compliments or like to recognize like weird hairline for haircuts, or like maybe you're into something very niche and you want to train a model to be very good at that, right? So I think having more tools like that open up the black box, and I'm not saying that everyone needs to learn like matrix multiplication and in depth, like how these deep neural networks work, but know enough to have the right mental model to know how to probe the model and know when to trust it and when not to trust it. And I'm seeing now like a lot of efforts on explainability of AI, or kind of exposing like some of the weights, or like what are the nodes in the network that are responsible for certain concepts. And it's almost like if you tune up that knob, right? Like there was Claude did an experiment where they changed their model. So whatever it would say to you, it would be about the bridge in San Francisco. And I would ask it about how do I pickle cucumbers, and you would find a way to make it about the bridge. So it was
Right.
kind of like showing people like, oh, if you tune on and off these knobs, or like increase the weights for this concept, this is what happens. I think we need much more of that across all layers, like for the developers to be able to access like the tokens and the probabilities for each prediction, for the users to have tools that expose like more layers of this black box models, and then for the applications to set the right expectations, right? And really explain to people like, we're really good at doing this and we're really bad at doing this other thing. And we need you to work with us to make it better rather than saying like, this is perfect, go and use it and then disappoint.
Right. I'm very curious just about you, Stefania. Where did you grow up, and how did you become so interested and intrigued by this kind of coding and science and AI development?
Yeah, I don't have a traditional background in tech, so I'm hoping to see many more people go through as many hoops as I did and kind of end up influencing this field. So I was born and raised in a very small village in Transylvania in Romania. I'm a first generation to go to college and to go to college in US or, and yeah, it's a long story, but basically from that village in Transylvania until getting to MIT and then UW and now Google, like
Wow.
there were
Wow,
there
that's
were
amazing. That's
yeah.
just amazing. How did you I'm gonna get into that because I think that's really interesting. How did you go from this small village in Transylvania to get to these higher levels of education and degrees?
Yeah, it's I think what helped, prime the first like kind of like pivot point was when I was a student in Romania in my first year when I was 18. I got involved with the student movement, with the student union, and we started doing a lot of projects at the time in education, and that's how my love for education started. So we started doing a lot of partnership between industry and academia to allow students to work on real projects rather than kind of learning fictitious, like solving fictitious
Yeah.
problems. And then Romania at the time was going through this major transition because we joined European Union in 2007, so we had to align how we teach to the European standards, but there was no plan for that. And then as students, we got involved and we said, like, this is how we do the credit transfer, or this is how we get like higher quality teachers, and this is how we incentivize the teachers, like and give awards. And this is so there were a lot of projects that I got to be involved in and learn about when I was 18 because I was at that right time and joined a student movement both in my Polytech University in Timișoara, where it's one of the towns where the revolution started in Romania, started by students, and then like at the national level, and also did a project with kids because the Romania joined EU. A lot of parents were going abroad to work abroad, and then the kids were left home alone. So we were like, what do we do? So a lot of the students, we started going to schools and kindergartens and kind of helping kids explore what their passions are. And when the parents would come home for Christmas, that like the surprise show to be like, did you know that your son loves to play the guitar? Did you know that your daughter is like really good at So we did this project knowing that current students are future parents and that we need to invest so much like in future generations. And so these were like the first nuggets of me getting really passionate about education and getting really interested in community organizing. And then I got to do a scholarship in France. Then I learned about a master's in education with new technologies that was in France, Spain, and Portugal, and got to do an internship in Peru training teachers. In 2008, I was training teachers in Peru to use technology in the classroom. And they were teaching, like they would draw a picture of the keyboard on the blackboard to teach kids how to use it. And then they only had cyber cafes. So we would go with the students and the teacher to the cyber cafe to get on the web. So it's like I saw this transition of technology going from teaching how to program on the blackboard or on paper to what we have today. And it motivated me. Like there were, like after this master's, like I started my own NGO where I was teaching kids science and technology around the world, but it was all project based. So that was very helpful because it was very much the same based on local communities. So let's say there's a group in Brazil, there's a group in Chile, or um, in Botswana, and they are like, we don't have access to Arduinos or to robots, but this is what we have access to, and these are the problems that are relevant in our community. Like maybe we need better solar panels or better water filters, or how can we teach engineering technology like while working on solving these problems and also making it fun for young people, right? So in 2012, we did the first maker faire in Africa, in Nigeria, and we inundated it with kids. Like we had kids from all these schools. At some point, they had the organizers were like, "Stop bringing kids," and they were just like all like eager to learn like how to solder, how to do like breadboard projects, how to program, how to. So I got to really see the power of building on people's like interest and also like allowing them to be agents of change in their local communities. And I definitely think with generative AI and with AI, what we're seeing now, like that's going to be the next big missing link. Like, how do we empower, and even using this word empower is a little bit uncomfortable because it comes from a notion that someone has the power and needs to give it to someone else. Maybe enable. Like, how do we enable local communities to build models that work in different languages, use these models for useful things, right? Like,
Mhm.
I don't want another app that is optimizing Uber to work with, I don't know, like, give me another, hey, it's
Yeah,
more like,
right, right.
it's like you have real problems.
Yes.
To, how, like we were talking about this last night, we had a bomb cyclone here in Seattle. So like a big part of belt, like surrounding areas still don't have electricity. Like how could we use AI to better do routing of intervention right after, right?
Right.
Or how? So I think like this is what's missing. And in order for this to happen, going back to your original question, like the first step is to make people feel less afraid. Like being afraid doesn't mean this technology is going away. And then the second step is uh, allowing for them to learn about it and learn how they could make their life better with it. Because if they're not going to do it, then someone else is going to try to come and do it for them, and that's not going to work out.
You were talking about your love for education and, the kids that are coming up today, the Gen Zers, maybe are now starting to have their own children, their own families, and the Gen Zers are really kind of the first generation that was totally born into this technological boom that we're living right now, and now their children's, their children are going to be totally far ahead. At what age do you think we can start introducing these concepts of generated AI and AI generated teaching to kids that still lets them be kids and develop in kind of normal ways where they want to be playful? But I know as a parent myself that the most critical time of childhood development is between 2 and 6 years old, where they just absorb everything and it's easy learning, whether it's a language or basic mathematical skills and concepts. So, is that the same application you look at for teaching generated AI and programming and those type of things?
Yeah, great question. So when I started researching how AI is influencing kids and how might we teach it, it was at the advent of voice assistants. So in 2016, 15, we wrote the first paper analyzing how kids perceive voice assistants that are in the homes and how that changes, like both how they engage with technology, but also how they learn. And in that study, we had participants from 5.5, 6 and up. And they were coming with their parents. And also I did a lot of studies in the home during the pandemic with the same group of families from all over US, all the states, all backgrounds and nationalities, and really seeing like what happens in the home. And it's not just the kids, it's also the parents or the extended family that influence, right? Like how this technology is being talked about, introduced, adopted or not. So it's important to also kind of work with the entire family, schools, the kids. And with the voice assistants, it was really interesting because age, as you mentioned, made a big difference. So the younger kids, like let's say like 5 to 7, were all very skeptical at the time of how smart Google Home is or Alexa, or like we tested several voice assistants because they were like, I know so much more about this topic, or I have an opinion about this topic, or but as soon as they went to school, like from 7 and up, or they thought that voice assistants were smarter than them because they have access to more information and they can kind of recite more information. So I think fundamentally that poses the question of what do we recognize this knowledge or intelligence in our society, and how do we teach that to kids? And also the recognizing that, Gemini, ChatGPT, these new generative AI are much more capable than voice assistants were back in 2016, 15. So then, like, the way youth position themselves or compare themselves to this technology or defer to it as a result is also going to change. And yeah, it's basically another thing I found is that the intelligence attribution colors everything else. So if they think the device is smart, they're going to trust it more. They're going to think it's more friendly. They're going to think it's more like sociable, that it will remember them. So it's like the intelligence attribution is at the base of all the other interactions. So explaining to kids, like, here's how machine intelligence is very different than human intelligence. And here's what this technology is good at. And here's what it's not good at. And here's like where you can come in. I think is going to be crucial. Definitely would not start with very young kids. I'm very much on board with you of like trying to to keep young kids away from devices as long as possible and encourage them to go outside. And I was actually teaching a class at RISD and NYU at ITP on designing toys for kids that encourage play away from devices and kind of enables them to discover the world also through embodied interaction, crafting, like being very active. So yeah, I think it's more challenging as a parent to navigate all of this now with all of this technology. And even if we are not going to teach generative AI to very young kids, it's still going to impact their world because the tablet is now the new pacifier, and a lot of the content that is created on YouTube for very young kids is going to be generated. And so it's going to impact their world for sure.
And that's the next question I was about ready to ask you is what role do you see generative AI in fostering creativity in young minds rather than just replacing it? So you want to use the technology to encourage their natural curiosity of exploration, trying
Mhm.
things, risk taking,
Yeah.
cognitive thinking, strategical thinking, versus just, oh, sit back, I'll become a robot. I'm just going to ask the computer to give me all of my information.
Oh, thank you so much for asking this question. This is something I research extensively and I'm still working on right now. So I think the reason we don't have more tools and resources that support co-creation or using AI to encourage youth creativity is a lack of imagination, and also the fact that, like Gemini, ChatGPT, all of these tools were not designed for youth, right? They are being used by youth extensively, but they were not designed for young people first. And I've been researching as part of my PhD how to design, for example, a Copilot for kids for creative coding for kids. And before building it, like the first thing I did, and this is a published paper, maybe we can share it in the show notes, um, was to actually do a Wizard of Oz. Like, I was the AI, like I was the kind of a character avatar coding with them, and then just seeing what sort of support they were looking for. Like, when would they ask questions? What sort of like ideas they wanted to get support with, or what worked and what didn't. And what I found was these were 9 to 12 years old. Most of them, they did not want the AI to do the program for them. They did not want the AI to code for them. They wanted the AI to ask them questions so they can figure out how to debug the code themselves. Or they
Right.
wanted the AI to give encouragement, like, oh, that's a great idea. Oh, you're doing awesome. Oh, I love how you did that. And and maybe like sometimes explain, it's like, oh, you want to make the character jump. How about we try to use this block because they might not know what are all the possibilities to express their idea into code. But in doing that, we saw the time they spent coding doubled or tripled, and all the parents were amazed. They said, "I never seen my child like spend so much time programming or focusing for so long." And I think like the advantage there is that having an AI pair programmer or like copilot is like they're infinitely patient, and also they can be very encouraging. So knowing that's kind of like the design space, then now I built like a version of that with a lot of safety filters and with a lot of like, but it's a very Socratic copilot for kids coding. Like it will never give them the answer. It's just like helping them figure out the answers themselves and asking them
Right.
questions so they get to refine their ideas more. So that's on the kind of like, how do you creatively code with AI, and something that I'm working on right now. The other part on the thinking, like you ask, how do we help them maybe develop better cognitive like strategies and processes, and give them new tools for new ways of thinking. I'm working on a project on math misconceptions. And basically, during the pandemic, we've seen a huge loss in math learning in K through 12.
Yeah. Yeah.
And together with my friend and co-author Nancy Otero, we listed all the misconceptions that happen in algebra in middle school, and based on prior work and prior research, and then gave that list of misconception to a model, and then use the model to analyze children's conversations or questions and see if it's able to identify the right misconceptions. And then once it identifies the right misconceptions, give them the right exercises so they can better understand that concept. So this is work that the benchmark is open source. It's on GitHub. The paper is in early preview, and we're working now with teachers and schools to be, is there a quick game or quiz that we could do in every class with your students? So you know, as a teacher, like, this percentage of the class still hasn't didn't understand the concept of fraction or division. So this is what I need to practice, right? So you could have like this quick check on where are the students stuck conceptually, and how are
Hmm.
these different misconceptions linked. Similarly, that's necessary be done in science, right? So if we have like better understanding of what are our misconceptions, and also show it to students, because a misconception, doing an error, is actually a very useful heuristic for learning. If I learn what are all the ways in which I could go wrong, that's going to help me think in a much clearer way moving forward. So these are the type of things and personalized learning interventions that we were not able to do before and we can do now. And multimodal does help, because I could put a webcam right above, and these are some demos I've done recently, AI engineering fair, like where I had a webcam and I would write equations and he would just ask me questions, or I would maybe make sketches about physics and he's like, oh, what should the G be here? Like, what should I try next? And it's like in real time, like analyzing my handwriting and asking questions. And for math, like being able to analyze like equations, drawing, like being able
Hmm.
to engage with more than just text is very helpful. And then the last piece I'm going to say for the creativity, that is something that really inspires me, and I think it's going to change the way we learn. I saw this yesterday. Someone asked ChatGPT, they have like a new version released for creative writing, to create a cipher in the style of Eminem about quantum mechanics. And the cipher was really good. The cipher is basically like metric rapping, and it's almost like spoken word rapping. And took that cipher, put it into Suno AI version 4, and it created an amazing song. And I was just thinking like, oh, what if we could teach like engineering concepts through like ciphers, or like what if or like there's models that create animation based on equations. Like let's say if English is not the first language for some of the students and they have a hard time visualizing in their head what's happening in this long equation, or creating an animation that shows that, like, it's gonna go, or creating simulations. Uh,
I think.
like
Well,
it
I think that's going to be fantastic because what we do know and we've learned since I was in school is the fact that people learn differently. There's not one way to teach mathematics and science. Some are visual learners, some are
Absolutely.
auditory learners, some like to have a demonstration where there's a teacher writing on a chalkboard and they connect in different ways. And generative AI can do all those different applications in different ways so more kids can learn and become, more productive and achieve their goals and dreams, right?
Absolutely. And I think that our preferred way of learning also depends on how much we know about a topic. Like if there's a new topic that I know very little about, maybe my first instinct is like, let me watch a quick video about it, right? And then like when I
Hmm.
get a little bit more information, like, oh, maybe I'll read a little bit the blog post, or maybe I'll go and like ask some questions on a chat interface, or but being able to support people based on their preferred way of learning and also like different level of knowledge and expertise, like that's something we could do now with generative AI that we were not able to do before. So I'm pretty excited about that. I'm also, I think, like what's coming, and it's going to be interesting both in terms of learning and creativity support, is this emerging worlds of agents. Like I've seen a project, someone is creating a long form book, and it's fully autonomous. Like you have 10 different agents collaborating in writing this book, and in real time you can observe how these agents are dividing and conquering the task. So you have an agent that is writing the script for the book, and another agent that is like verifying the coherence of each chapter, and an agent that is searching for references. So you have like, 10 agents, and you can literally see the creative process of how the book comes together.
Hmm.
And observing that, and then also being able to interfere and be like, oh, I think this agent didn't do a good job here, or like I actually want to write this chapter, and like, or I want to see how the agents react if I change the specification in this way, or but just having almost like a blueprint, like what does the creative process might look like for a book versus coming up with a story plot for a movie versus, I don't know, right? Like pick any
Right.
task. Um, that's gonna be interesting. It's almost like simulating creative worlds and understanding, like visualizing a little bit more what that creative process looks like.
Well, they do that in engineering right now all the time.
Yeah,
We talked to
exactly.
a senior engineer who was developing this underwater habitat, for people to be. It's uh, one of these things where people will live like the International Space Station in the ocean, basically. And they can't just go down there and build it and hope it works. They have to create models and visualize things in a digital space. And so you're talking about the same thing with creativity, which I think is fantastic. I don't know about you, but I remember, because I'm older, I remember when the Texas Instruments calculators came out, and
Yeah.
how our math teachers said absolutely no calculators used during the test. You can't do it. It's got to be on pencil and paper, blah, blah, blah. And then, like, 2 or 3 years later, yeah, bring the calculators in. It's okay. It doesn't matter. Do you see a day where kids will be able to have their little, you know, Gemini, program here on the phone in a class, and the teacher will say you're allowed to use generated AI to help you, with a test. Do you see that even being a possibility?
100%. And I'm so glad you used the calculator example. Like that's something that came up last night. We were having a panel conversation on AI ethics, and someone shared the calculator example.
Yeah, yeah,
One, so it's definitely in the social imaginary world, imagination. Like, and we had a parent who was asking, like, my son is using these tools for writing essays, and I need to talk to him, and like, I don't want him to cheat. How do I do that? And I think that's a lot of responsibility to put both on the kids and the parents. And so ultimately, the solution is to change the assignments, right? Like to change the assignments and to change the way we evaluate them. Telling young people and kids not to use generative AI, it's not gonna work, right? And we've seen investigation. The New York Times had this article on false positives because now all the schools are using this tools to kind of detect if they use generative AI, but there are a lot of false positives, and that can cause problems as well. So
right,
ultimately, like there needs to be a trust and a rapport, and instead of banning it, telling and helping kids to use it in critical ways, in creative ways. And maybe is like, okay, like let's see what Gemini gives you on this topic and critique it, or like let's see how what questions can we ask to get it to do a mistake, and why does it make that mistake, or let's use it to give an answer from four different points of view and discuss like um what we agree or disagree. And it obviously depends on the assignment and the class, but I really think that we will need to get to a point where it's being used as a calculator. And another analogy for me is Wikipedia. When Wikipedia came out, like schools were really freaking out and they didn't want kids to reference Wikipedia. They didn't want to use it in their homework. And now, like we wouldn't have LLMs without the Wikipedia. And Wikipedia
Right.
is actually, it's such a beautiful testament of collective intelligence. I mean, it's not perfect. There are lots of issues, but it is a testament of collective intelligence at its best.
Right.
So how do we use generative AI to reach something similar, but make sure that people, and especially novices, still learn and have the right level of
Well, I think
literacy.
yeah, I think the key, and you talked about it earlier, is the fact that, one thing I, as a parent, and I have observed in my own life and rearing my kids, is the fact they want to figure it out themselves. They that's where self-esteem comes from, is to being
Happiness.
able to be confronted with a problem and to solve that problem, figure it out, work through it. Even if you fail a couple of times in doing it, you eventually get to the right answer or you solve the issue and then you move on. And I think as long as it's programmed and designed in ways that just challenge the kids to, that's not quite the answer. What do you think this might be? What do you think? What do you maybe try that? As long as they are being encouraged, but not just spoon fed the answer, I think
Mhm.
just as an observing, just as a parent who's gone through this, we want to have kids to always have their own self-esteem and their own self-worth. And if it's just spoon fed to them, they will not develop that. If they're encouraged to keep trying and not be admonished severely or punished, so to speak, because they fail, and realize that failure is part of the process to succeed, I think that'll be the key.
I 100% agree. And yeah, I think for that, it's important to bring parents along, bring teachers along, and also make it very clear that the need for teachers is not, we're always going to need teachers. And maybe it's even more important now for them to kind of guide this critical process. Um, and yeah, I totally agree. And I think at the end of the day, it's just a tool, it's just a technology. And we decide how and when to use it in order to support our creative self-efficacy, our self-esteem, develop our identities, personalities. And I can tell you, like, I love when I had 5 years old and they were playing with this Cosmo robot or Jeepo, and I was like, yeah, it's smart, but it doesn't have a personality. Like this is something
Mm.
new for very young kids. Like at the core, like they really care about the personality.
So Gemini, ChatGPT, these are all open source, right? So people from all walks of life, all levels of understanding and education around the world can contribute to enhance these things. How do you set up guardrails to protect from just somebody tainting it with, you know, evil? That's for lack of a better word, but just things that are not positive or not encouraging, but are destructive and discouraging. How do you protect that?
Yeah, there's multiple layers to this question. I'm really glad you asked that. So Gemini itself is not open source, but Google has put out models that are open source, like Gemma. These are smaller models. Um, so with a smaller model, the idea is that there's less of a risk of doing harm at scales. And then the Gemini models, the large ones, are accessible via the API. So you can make calls programmatically to the model in your applications. And this can be any type of applications, including for education. But there are filters on those, right? And then there's like that's another form of guardrail. And similarly for OpenAI, ChatGPT is not open source, but like they do have APIs for their models. I don't know if they have models that are open source, but they have APIs. And then there are alternatives like Mistral is a French startup. They have like high quality models that are open source. And of course, Llama was the first one from Meta that was like the largest open source model, and people were very worried like that it will be used for nefarious purposes. Um, that risk is always going to be there. Like I think one argument I hear in the open source communities is that if it's open, then the community, then it's more transparent and you know what people are doing. And then you can kind of be like, hey, you should not use this data. Or if you use this data, like here's like some kind of licenses that you need to attach to your application, or here's some guardrails. Or so as long as it's transparent, like it's easier to monitor for use cases. And so that's one argument. Um, the other problem is really the expertise, like the amount of people who can do this type of work and build this application is limited. I mean, there's a really high competition right now for hiring talent in this space. Um, so I would say like the biggest bottleneck right now is like the expertise and like how many of these AI engineers and researchers like because it's so competitive would want to use their skills to work maybe in domains or applications that are less lucrative but highly impactful, right? Like in education, in civic participation, in climate change, like so that's where, like, again, going back to education and making sure that we encourage people coming from different careers or coming from very different backgrounds and who have domain expertise and want to know how to use these tools, like to feel like they're welcomed, part of the conversation, and could also use the tools, but also collaborate with people who know how to use the tools very well for creating applications that might not have like a business model, but could have a high social impact.
So, as a research scientist in all things AI, can you extrapolate what you know into what's going to happen in 10 years, maybe 20 years?
Yeah, I think in 10 years, we're definitely going to have more efforts on having more sustainable architectures that can su- support like this technology with less power, less compute. That's something that is a active area of research and a big problem to be solved for. I also expect to have models in 10 years that work really well in many other languages than English. There's research right now, there's an open source model called Aya that works in 20 languages pretty well, but there's a lot of work to be done to support this technology in many more languages, ideally in all the languages, because there is a snowball effect. Like if the content we create that gets put on the web is primarily in English or in the main languages, like that data gets trained, put into the new model. So we want to make sure like we're supporting culturally inclusive applications, and I
Hmm.
really hope to see this in the next decade. And then also more unique and kind of creative applications. So it's not just text and chatting with everything, but it's embedded in our personal devices. You can take it out into the world, and then you could interact directly like with video streams, camera streams, and I expect these technologies to become proactive as well. Right now, they're very reactive. We're the ones initiating the contact, but I expect these technologies to become proactive. So if my phone sees like I'm always calling a person at a certain time, they can propose to create a calendar event or a routine for me. Or so I expect like proactivity, more sustainable compute and architectures, and multilingual applications to be commonplace in the next 10 years.
What about really restrictive controlling regimes like Russia and China who, really have severe limits on what their people can access, on the internet and things like that? How does this technology impact them? Will they be way behind or can they still participate in the growth of generative AI?
That's a tricky one, given that we have active wars ongoing and a huge transition of power upcoming in US. So it's very hard for me to know how that would unfold in the next decade. I'm
Hmm.
hoping that people will be able to participate, like we've seen with the restrictions in China that people still use VPN and they get very creative about how to work around those restrictions. And we see a lot of models and technologies coming out of China, for example, in the generative AI space. So
Okay.
my expectation is that even if there are restrictions, people would find workarounds and will be able to participate.
One of our questions that we always ask on this podcast is, what are you most curious about and what keeps you up at night? But I have to tag that on there. Being from Transylvania, I just have to ask you, did you have, nightmares of Dracula when you were a kid?
I did not. The castle is very close from my house. It's like 20 minutes drive. I got to visit
Wow.
it several times, and the legend is based on a real story of Vlad Tepes, Vlad the Impaler. So I learned his story in school, and I think I was more kind of intrigued or thinking about how did he manage to face the Ottoman Empire with such a small country and group of people. And there were lots of lessons there because Vlad was kidnapped as a kid by the Ottomans, and he grew up, learned their ways, and then that's how he was able to kind of fight strategically against them and make sure the Ottomans don't conquer what was Romania at the time and then Europe, Eastern
Because he
Europe.
was embedded with them and he learned everything about them to
Correct.
use against them. Yeah.
Correct. Yeah.
So is
So,
AI learning back then?
I was thinking there's probably an analogy here, but
Yeah,
yeah,
for sure. So what are you most curious about?
I am very curious to keep working with young people with these tools because I think the way they probe them, poke at them, use them is so much more creative than adults. They're not condition of okay, I need to become more productive and do more of this and more of that, kind of um, taking our status quo and ecosystem of society and technology as a given. And it keeps me up at night of what would be the most creative way to stimulate kids' imagination and enable it with this new technology. So that's something I think a lot about, and kind of this what does a community of creating online like Scratch looks like when half of the users are AIs and half are kids, and they collaborate and kind of fork and remix each other's creation. How do we navigate that? Those are the type of things that I think a lot about.
And I have a feeling that you're going to figure it out because that's your groove. So, Stefania, thank you so much for being on the Ignition Sequence podcast and informing us about generative AI. And we'll have you on again 5 years from now when it's even farther down the road and we can talk more about it. We really appreciate it. Have a great day.
Thank you so much.
Ignition Sequence is produced by Accelerator Media, a nonprofit organization dedicated to inspiring a lifelong pursuit of knowledge. The podcast is made possible in part by viewers and listeners like you. If you'd like to support our work and help us continue bringing Ignition Sequence and other programs to a global audience, please visit acceleratormedia.org and click the donation button. Your contribution helps fuel our mission to ignite curiosity and empower future world changers. Listen, learn, repeat.